All right, so this is our introduction to matrices and matrix operations. So for some of you, this is going to be a review. For others of you, this is brand new information, okay? And we're going to start off, so I'm going to teach it like none of us have ever seen it before, because that's really the only fair way to do it. And just, well, maybe I'll do it. I'll after we get started, I know you're going to think, when the heck would I ever use this? We'll talk a little bit about that too. So what is a matrix? So I don't know if, but for some reason that bracket doesn't print right on here, or it doesn't look right on mine anyway. I don't know if it looks right on yours. But, oh, I don't even know why it won't let me right. Okay, there we go. So, you know, it's actually like a bracket there. So what a matrix is, it is a rectangular array of variables or constants. So letters or numbers, all right, variables or constants in rows and or columns. Most writing you'll have to do today. So a rectangular array of variables or constants in rows and or columns, usually enclosed in brackets. I mean, I'm not going to quiz you on the definition or anything, but it's always good to have the real definition. Okay. So you have a matrix. You have a brackets, and then you have numbers sitting in their little spots. Okay, like eggs in an egg carton type of thing. So there's elements of the matrix. So this is what a matrix looks like. Then we're going to talk about what the elements are. So the elements are the individual values within the matrix. They're the numbers that you see or the variables that you see. Okay. And then the number or the elements are referred to in specific ways. So if I have an element and I have lowercase a and then x, y down here like that. Okay. So a and then x, y is like the subscript there. It is used to denote each element where x is the row number and y is the column number. Oh, that looks like column number, where the element is located. So what that means is this. Let's look at these little examples here. And it's always row then column. So what looks like A25 right here is actually A25. So I go to the second column. I'm sorry, no I don't. I go to the second row and I go to the fifth column, and that element is -2. You see how that works? The 2-5 means I go to the second row, fifth column. So this, what looks like A31 is A31. So I go to the third row, first column, my number is 5. You understand how that works? It is not, no. It kind of, I see what you're thinking. Pascal's triangle, that's what you're thinking of. It is not. It's not related to that. Yeah, so, good question, but no, so don't get it mixed up. This part right here, for right now, yes. And then, you'll be given that in some sort of way. Maybe we have some variables in there we have to solve for later, but we'll talk about all that later. But yes, you're basically given that. All right, so you fill in the other 4 right there. Find those elements. And then once you're done, check yourself with me. Do we agree? Do we all understand how to read that? Because it's not difficult, but if you don't understand what the heck it means, it's a problem. All right. I'll take that as we are good. All right. So the dimensions, which can also be called the order of the matrix, and I'm pretty sure in Delta Math, it doesn't ask you for the dimensions. It says state the order. It is the exact same thing. Okay, just a different way to say it. All right, so a matrix with m rows and n columns is an m by n. So it's not really m times n. It's like m by n. Like if you have a rectangle that's 8 by 12 or something like that. That's what we're talking about there. It's an m by n matrix. We're not multiplying. And it always goes rows times columns. So when I'm answering these then, if it says state the dimensions or the order, then rows, how many rows do I have? 1. How many columns do I have? 3. So it's a 1 by 3. So 8, how many rows do I have? 4. So it's a 4 by what? 2. Very good. All right, you do the next 2. And then I'm going to, I got this student selector here to make y'all answer questions. So watch, it's like a little claw thing. All right, Nevaeh. What is number 9? 3 by 4. Very good. All right, let's see who's my next assistant here. Yuretsi. 4 by 2. 2 by 6. She's making stuff up. Okay. You just read the wrong one, didn't you? Okay. Are we good on that? Easy enough? So that's the order or the dimensions. And the dimensions are going to matter when we do certain things. Okay. So then we have some special little definitions of things we need to talk about. The first one is equal matrices. And so these are 2 matrices in which each element in one matrix is equal to each corresponding, oh my goodness, these are not enough lines, corresponding, and then I'm going to finish it down here, each corresponding element in the other matrix. When I wrote it down, well, when I wrote it with a pencil, it was fine. When I write it up here, I can fit. So write bigger. We're all good on that? That just means that they're identical, really. They have to look exactly the same. That's just the more official way to say things. All right. So then special matrices. A row matrix would just look like this. A, B, C. It's just, or whatever it is, right? It's just literally one row. And however many columns, it doesn't have to be 3. So a column matrix would look something like this. X, Y, Z. A square matrix is just what it sounds like. A square, R, S, T, U. So any dimension, as long as basically the dimensions, it has to be like a 2 by 2 or a 4 by 4 or whatever. And then a zero matrix could be any size, but only have zeros in there. And I know you might be thinking, why the heck does that even matter? You'll understand why and why we would need that when we get to some other things. Okay? What questions do we have? Anything at all? Okay, let's flip it over and let's do some very basic matrix stuff. So matrices can be added or subtracted if and only if, that means only in this situation, they have the same dimensions. Okay? So when we do that, we just simply add or subtract the corresponding elements. So it says, using the matrices below, perform each operation if possible. If possible. Right? So this tells me I want to add x plus y. Do x and y have the same dimensions? Yes, they do. Then that means I can do it. So I'm going to just make my little matrix here. And so when I add the corresponding pieces, I'm taking 24 and adding a negative 15 because they're in the same spot. What is 24 plus a negative 15? 9. Okay. And then negative 4 plus 9 gives me 5. And then negative 8 plus 29 gives me 21. 6 plus a negative 5 is 1. Negative 3 plus 17, 14. Negative 17 plus a negative 2 is what? Negative 19. Okay. And there's my answer. Easy enough? We good on that? All right, so let's look at 13. I know I skipped 12. We'll go back. 13, w plus x. W plus x. Do they have the same dimensions? No, so then I can't add them. Do you understand why? Because things don't match up. So this one is just not possible. All right. You do 12 and 14. And then I'm going to look for some helpers. Question. Why do you think this one's not possible? What does this say? X minus y. Oh. All right, let's see who's going to be my next helper. I think I can. Oh. Sophia. Are you done with this? Are you done with 12? All right, so give me a row at a time. Okay. No, I mean, like, give me the numbers is what I meant. Like, row 3, you're going to be you're getting fancy here, okay? 4 and 29. Okay, wait, give me all of them. I just meant, like, say them in rows. You're fine. Above it? Positive 5? Negative, good, yeah, right? Because you're going to do negative 16 minus a negative 11, right? Yeah, okay. So negative 5, and then what's the other one? You sure? Z negative 15? You sure? Negative. I think you subtracted the opposite way. I don't know. You got the right answer on the last row. Yeah, no, it's okay. I mean, it's easy to do. It's fine. But -3 minus -1, so it's gonna be -2. And then -2 minus 9 is negative. Yeah, yeah, I understand. Yeah, easy mistake. Like, this is easy to do, right? But it's totally easy to mess up too. I mean, yeah, gotcha. We good? Well, it literally says z minus w, so you have to do z minus w. Does that make sense? You don't get to decide. Like when you add, you can add in any order. It doesn't matter just because that's the way adding works. But with subtraction, it makes a difference. Okay. Good question. Anything else? We good? All right. What's my next helper here? Oh. I guess I was able to move my mouse. Maybe that's what I was doing. I don't know how I got it to move the thing. It doesn't matter. All right, Siri. Did you want to give me a row at a time? Okay. -13? Do we agree with that? Maybe not. Oh, I'm sorry. Gotcha. That's a column, but okay. There's just, hang on a second. Because I want to make sure everybody knows, since you said that, I didn't think about this. Make sure we know the difference between a row and a column. The rows go this way, the columns go this way. Does that make sense? Which is fine. It's fine that made me think that maybe we don't all understand what's what. So let's make sure we know. Okay, you're fine. You give it to me a column at a time then. What's the next column? Okay. You can give me the column, whatever you want to do. Just let me know so I know where. 11, okay. Yeah, gotcha. All right, and then, -15. Okay, good. Do we agree with that? We good with that one? Okay, good deal. Any questions at all? Okay, so there is a way to multiply matrices together. That is not what we're doing today. Today we are doing what is called scalar multiplication, which if you've ever done anything with vectors, you can do scalar multiplication as well. So matrices can be multiplied by a constant called a scalar. So the constant is just a scalar. That's why it's called scalar multiplication. In this process called scalar multiplication, each element in the matrix is multiplied by the scalar to produce the new matrix. So you're going to have to look up at the top there to be able to see your x's and y's because I can't. We're using the same matrices. So if I'm going to do 3 times x, okay, and the matrix is x, 3 times 24, can anybody tell me what that is? 72, very good. And then what do y'all want to do? Y'all want to go in columns or rows? What makes more sense to you? Rows? Okay. So then 3 times a -8, -24. 3 times a -3, -9. Then 3 times -4, -12. 3 times 6, 18. 3 times a -17. Negative what? 51. Okay. All right, so then we have 3/4 times w. And we go with the fraction, all right? So what's 3/4 times a -1? -3/4. I probably shouldn't have made my bracket yet, though, because I'm probably going to need to make it longer. Fractions. I'll wait. -3/4, and then 3/4 times 9. And if you needed, like, if I do 3/4 times 9, can I reduce that before I multiply? No. So that's just 27 over 9, right? 27 over 9. And then, wait, over 4. Oh my God. See? That doesn't make any sense at all. I think I'm making stuff up. And then I'm going to do 3/4 times -11. Would I be able to reduce that? No, so I just multiply straight across and get -33 over 4, because that's what makes sense. And then 3/4 times 15. 15 doesn't divide by 4, right? So what's 3 times 15? 45, so this is 45 over 4. Then I got to do 3/4 times 8. Can I reduce that first? 3/4 times 8. Isn't 8 divided by 4 2? So then it's really just 2 times 3, which is 6. And then negative 20, so 3/4 times a negative 20. What's negative 20 divided by 4? Negative 5 times 3 is a negative 15. Okay. Sometimes you're going to have more than one step. Okay, so on 17, we have more than one step. We have to multiply each one by a scalar and then add them together. So if I need to do that, I'm going to start with the negative 5 times x. So what's 24 times 5? Is it 120? It is 120. Yeah, got to be confident in your answers. 120, and then negative 4 times, I've lost where I am. Negative 4 times 8, that's going to be a positive what? 32. And then, that was negative 4. It's, oh my God. Jesus Christ. No wonder y'all didn't answer me. Negative 5 times negative 8, that's a positive 40. I did 4 for some reason. I don't know why. And then, actually, just do this. Do negative 5x and make your little matrix right here. Because I can't even say the numbers. You go ahead and fill in this matrix by multiplying by negative 5. I think you understand what to do. I just can't look up and down, apparently. And then we're going to add it, because you can add it to another matrix. And here's what matrix addition looks like when you're not just using the names. It's literally this matrix plus that matrix. Then we're going to do 2 times y. So that should be pretty easy, right? That's going to give me negative 30. It should be easy if I can do this. What's 2 times 29? Anybody? 58? Yes. And sorry, I'm looking at the wrong numbers on here. Goodness, can't do it right here either. 2 times 17 is 34. And then I don't trust anything I'm doing anymore. Negative 10 and negative 4. Do we agree with that? Okay. So now I've written out my 2 matrices that I'm going to add together. They are the same dimensions, so it works. And so in the end, when I add them together, negative 120 plus a negative 30 is a negative 150. 40 plus 58 is 98. 15 plus 34 is 49. And then 38, negative 40, and 81. Everybody okay with that? Do you understand how that works? Okay, now, what if I have, so basically you're just substituting in and doing exactly what it shows. When you look at number 19 here, and we have negative 3 times w plus z, so then I'm going to have negative 3 times, and then when I look up here, can I actually add w plus z? Are they the same dimensions? So I'm going to do my order of operations and do basically the exact same thing that I did before. W and z are the same dimensions. So negative 1 plus a negative 3 is negative 4. 9 plus a negative 2 is 7. Right? And then, negative 27 and 15. And 20 and negative 11. So you're doing this just like normal algebra. Like you would add first and then multiply by a negative 3. So then in the end, when we multiply, we'll get a positive 12, negative 21. Uh-oh. Positive, what's 3 times 27? 81, very good. And then negative 45, I like the big sigh before you give me the answer. And then negative 60 and 33. Do you understand the process there and how this works? Okay. So I'm going to give you a couple minutes. I want you to finish up 18 and 20, and then I'm going to look for other people that are going to be volunteered. Let me know if you're stuck or confused. You look stuck or confused because you're staring. Are you, or are you just not? Okay. Okay, that's okay. If you're done, you can keep it out so we can go over it, but if you're done, you can go ahead and get your computer out and get to Delta Math. Remember, you have to go through the portal, or you have to go through Canvas to do that. But well, I'll let everybody else finish up, and then we'll talk about what the answers are and make sure that we're correct. It's there now? Okay. All right, now you might have to refresh. All right, but now that you're there, let's just double check this. Let's see who my next helper is here. Sophia, again, it likes you. So, which one do you want to give me? I'll let you choose. 18? You want to do 18? Okay. Are you going to give me columns or rows? I don't care. Just tell me what I'm doing. Okay, got it. What you got? Uh-huh. Good. Okay. Okay. 50 and negative 89. Okay. So my paper says 60. Where'd you get 50 from? Do you not even know? So you have because you wrote.
Oh,
you wrote 50. Okay, got it. Okay, yeah. So this is actually 60. I just want to double check that my paper was right, but that's actually 60. Okay, we agree with that? That's what we should get for 18. We all good then? All right, so let's see who my last helper of the day today is. Sandra, she's not here. See her again. I'll take y'all out next time, but chose not to. All right, so now you get to give me the last one. You want to get? Are you giving me columns or rows? Rows. Okay. What do we got? Okay. 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 Do we agree with that? So anybody else, when you get something like that, does it make you think your 10 might be wrong? It does for me. But all right, I agree with that too, but I don't always agree with myself. So we good? Beautiful. Awesome.